All right, this is Brian. Here's Greg from Gill Data Recovery. And we're going to talk about kind of all things logical data recovery, which can kind of encapsulate a lot of different types of situations we see in the lab. Everything from I accidentally deleted a few files, to an IT guy deletes a whole logical unit or LUN on a big SAN.
System restores,
accidental reformats, kind of all the different things that can happen where the storage equipment is healthy, but the data went kapoofs.
Data's not accessible.
Not accessible anymore. In order to understand a lot of these scenarios, we're going to have to give you just a little bit of File System 101. So Greg, if you want to kind of do that and try to dumb it way down for us.
Sure. File system basically just refers to the means that your operating system uses to catalog and store data on your secondary storage device, whether it be a flash, SSD, mechanical hard drive, floppy disk, optical disk. There's going to be some programmatic way of cataloging and retrieving information from that disk. So file systems, a few buzzwords. If you're running Windows, you're probably going to be running NTFS. If you're on a Mac, you're probably going to be running HFS Plus,
APFS,
or APFS, which is Apple's new bright, shiny new file system. And if you're running Linux, you're probably going to be running ext4, or maybe XFS, or maybe ButterFS,
or
Butterfan here. So there's a variety of ways of doing this, but
these are all brands or flavors of file systems, and
each has their advantages and disadvantages.
So what is it? What are they doing though, Greg?
It's basically a way of, as I said before, cataloging and retrieving information on disk. They all accomplish the exact same task. So if you want to think about a disk as just a linear block of storage, got these data blocks that can hold an amount of data. A file system, basically, when you format a volume, is going to set up its internal data structures for bookkeeping. So that's probably going to be a super block here that basically serves to identify as an NTFS file system or an HFS Plus file system what type of file system it is. Probably some directory structure, and then probably some records for files. And then the remainder of these blocks are available for data. So an important thing to note is that the metadata for the file system is stored right alongside the data itself. And exactly what kind of makes the distinction between data and what makes separates data from metadata is all up to the file system. But it's basically a way of saying, so when you tell your operating system to open resume.doc, it knows where the actual data for resume.doc is stored. So basically your file system keeps all this file metadata, and then when you create a file, so let's say we put resume.doc on this file system, it's going to basically have a listing for resume.doc in your directory, and it's going to create a file record for resume.doc, and then it's probably going to take one or more, or actually it's going to take one or more blocks for the actual file data. So this is Greg, I work at Gillware, I am awesome, yeah, stuff like that.
All right, so that's, again, without completely losing the audience here, we got to walk through kind of some of the scenarios that we actually see kind of commonly, give people ideas for how recoverable these scenarios are going to be, and eventually what they're going to cost. So we're going to start with the simplest, file deletion. I accidentally deleted some files. And the good news is these are usually pretty recoverable, but there is...
Depending on the type of storage.
Depending on the type of storage, but also depending on how many new files have been created since the event. So it's not really a function of time, but if you want to retrieve those photos that you deleted 3 years ago and you've been using the system ever since, you're probably SOL, and that's an acronym I will not spell out here, but there's a really high probability that the data has been overwritten. So once data is written to one of those blocks that were here, we really can't, for the most part, rewind time and get those blocks back. But what typically happens, so if we're looking at kind of a typical Windows file system, You know, Greg says, oh, there's some sort of a super block here, and it's going to point to this thing called an MFT or a $MFT file. And this is basically going to be the data dictionary that's going to hold all the actual inodes that say, my name is Bob, I'm a resume, and I live in this folder, and this is the place on disk where I live, and I'm a Word document. So all that information is going to live in about 2 kilobytes. That's going to live inside of the data dictionary, which lives inside of the $MFT file in NTFS. So, you know, Bob's resume.doc is going to be here. It's going to have about 2 kilobytes devoted to it, and it's going to point to this place out on disk where the actual, you know, docx file that is actually a zip file under the covers is going to be here. When we look at it, we're going to see the hexadecimal, you know, probably PK or whatever we see,
Mm-hmm.
and this is really the contents. Traditionally, when you delete something, it's basically going to flip a bit in here from a 1 to a 0 or something that says, hey, I'm deleted now, right?
Basically, it says this record location is available for use for a new file.
And it probably won't even do that yet, because on Windows, it's going to put it in the recycle bin first, right?
You said delete, not recycle. Semantics.
This is why his employment is
Nice.
very tenuous. But so anyways, so in Windows, there's a couple stages before this happens, but at some point, this is going to say, listen, this record's been deleted. Now, when we look at this in our systems, or you might even use some off-the-shelf data recovery software, when it scans the existing geometry for the master file table, it will sometimes see this, and it'll say, oh, there was a document called bob.doc that was deleted, and it used to live here. And then sometimes this disk space has not been overwritten, because fate just decided that you didn't overwrite it yet. And when this happens, the recovery software or the Gillware engineers will find your old Word document. So we'll be good to go. Sometimes we find this, but this has been permanently killed.
You created a new file called jimmy.doc. And for whatever reason,
And Jimmy got written here.
got written there and overwrote the top half of Bob or something.
Yeah, so we see that kind of thing from time to time. Complicating matters. And this is why, why would anybody send this stuff into Gillware? About 80% of the logical cases that come into Gillware, we get a whole bunch of data back, and almost all of them have been at a local IT professional to do some sort of off-the-shelf data recovery software.
Some of that software is very good. It's in the situation that you described, any of that off-the-shelf software should be able to slice and dice that pretty quickly.
But what we find is that there's a lot of underlying complexity sometimes with these file systems, and we don't want to dive way too deep, but sometimes these file systems are snapshotting. Greg, what's a snapshot?
Snapshot is basically a mechanism that allows you to preserve the way the entire volume looked at any given point in time while continuing to use them and make changes to the volume.
So, and basically we can sometimes rewind at a block level some of these events to point in time and then run our normal, similar to off-the-shelf software and actually get dramatically better results than somebody who just ran some software they've never used before or used once or twice. So, the long story short is most of the time we're able to help people. Certainly there are situations in these logical worlds where we can't help people. Those people don't usually pay us any money, which is nice, but we don't directly help them by recovering some of that data. The vast majority of the time, if we're unable to recover the data that you covet, or a lot of it, you're not going to pay us any money. Most of the time we can help. And the very next question that we always get is, what is this going to cost? And it has a lot to do with can Greg's junior subordinates on the engineering staff, can they run our platform called the Ombre that Greg and I have written a bunch of code in? Greg more than me, a lot more than me. A lot more than me. Okay, Greg, give me a break. I wrote some of it.
I think you put a regex in there too.
Yes, I have written regular expression parsing many times, and that is an insult that most of you will not pick up on. So at the end of the day, though, how much engineering effort is it going to take is almost where all these bills come from. We see cases where the answer is next to 0, which means 1 or 2 hours around here. And we might charge a client $300 total for a situation where you used this much of our time. It's not super common. Most of the stuff that gets sent to us has already been through the easy.
If it were that easy, you would have probably taken care of it at a local tech shop or taken care of it
You wouldn't be
yourself.
watching this video.
Yeah.
For the most of the time, if it was that easy, you would not be watching this video. We see scenarios where it takes a big brained computer scientist maybe half a day in order to recover your data. Your bill may look like $800 or $900 if that's the case. And we also see cases of kind of dramatic complexity where it is a file format that we're unfamiliar with. It's some sort of old CNC machine that's 18 years old, and it has a file format that we've never seen. We have to research that file format, write a bunch of code to find all the orphan data, and then write a bunch more code to test it and verify that this stuff works and this stuff doesn't work. And those bills can be thousands of dollars. But for the most part, if you are looking to have data that was deleted, that was of known file formats and known file systems to us, without a lot of encryption going on, you're probably going to be looking at, I would say, well south of $1,000. You know, I would say kind of a normal, I deleted a bunch of data, I'm a normal consumer running Windows, what is this going to cost? It's usually $500. Is that fair?
I'd say so, yeah.
So that's deleted file situation. One thing we're going to talk about real quick, what if that file I deleted was a virtual machine?
Oh boy. Well, that basically adds another layer of complexity to the problem, because if you think about a situation like this, we are directly recovering a file which contains the data that you're concerned about. So we're basically going right from disk to data. Real nice, real easy.
What's that movie with Leonardo DiCaprio? It's like that. Inception.
Okay.
You know, we're in kind of Inception land where this whole thing we just made is actually a file within another universe. So long story short is that 3 or 4 hours of computer scientists to get an optimal result. Might be 40, might be 80. I mean, we've seen all kinds.
Depending, yeah. What
Might
was
be 10.
What was your hypervisor?
Yeah, and in general, our computer scientists and digital forensics personnel that have thousands of hours of experience and usually like computer science degrees, and have put in their years of study and effort here and seen these situations many, many times. When these people are directly helping you, it's usually at like $300 an hour. So certainly, sometimes this is not as inexpensive as we would like. The more complicated your problem, usually the bigger the bill. The way it works is we always look at it for free, perform a complementary feasibility study, figure out what the heck we're up against, and we'll try to guide your expectations as best we can. So shifting gears to reformat. Greg,
Sure.
what happens when I reformat this volume?
When you reformat, basically, it creates a new super block right over the top of the old one, in most cases.
So that's gone. We don't get that back.
Mm-hmm.
And that used to say there was a partition that lived from here to here, and it's NTFS, and we just lost that information.
And then it creates a new master file table, usually pretty small, right smack dab over the other one.
But a lot of the file records from the previous regime might be here.
Mm-hmm. And again, if you were to basically take some off-the-shelf software, sometimes it's only going to look at the active MFT, and it's not going to look for file records elsewhere on the disk.
And if you're watching this video, it's probably because that didn't work, and there's a lot of reasons for that.
Mm-hmm.
So determining the old regime's file system geometry is pretty darn tricky. You have to hope it's very, very similar to the current file system geometry.
Mm-hmm.
And if a cluster size changed, or partition type changed, or
there's a lot of variables here, and to make the software easy to use, they have to make some assumptions.
And this $MFT or file table or data dictionary is often fragmented.
Mm-hmm.
And there might be chunks of it out here, and chunks of it over here, and chunks of it over here. And the job of the, in our case, an investigator or a computer scientist, the job is to figure out what the previous regime's file system geometry was. Oh, it started here at sector 2048. Not sector 63, which the dumb software figured out. But our people can say, oh, listen, we see evidence that this is where the file system starts.
Why is the start important?
Well, what we find is that these master file table entries are relative. So they don't they don't say I live at sector
Absolute
17 million.
addresses on the disk. They don't use absolute addressing.
Yeah, they're addressed. If this says 17 million, I live at sector or cluster 17 million. It's talking about from here.
From the start of the file system.
Right.
Start of block 0.
It has no concepts. These individual files have no concept of the greater universe outside this disk. They don't know if they're running on a RAID 5. They don't know if they're running on a single disk. They don't know if they're on a thumbstick. They've got no concept of any of this. So if you guess wrong, you find all the file definitions, and this is a very common call we get. Yeah, my software ran and it recovered all kinds of files, but none of them work. And a lot of times, that's because the software you ran guessed the wrong geometry. Or it might know the start of it, but it doesn't pick up on the fact that the cluster size changed. But we got to find the relative start of the maybe multiple partitions. We have to scan that new geometry for all the chunks that we find that sometimes the old software, it didn't know to scan the whole disk to go way, way down here for a big chunk of data that's important to you. And then ultimately, we need to use this data dictionary information to find the individual files. And then we take things one step further, and we actually, for the most part, can look at the files themselves and see if they make sense. Do they have binary headers that make sense? Do they have binary footers that make sense? And we roll all that up, and we'll actually tell our clients, like, these files work, and these files almost certainly don't. So that, we don't hand you back 17 million files and
You can make a well-informed decision whether or not to basically purchase the recovery.
well, and when you do decide to purchase the recovery, because you will, you won't have to waste a whole lot of your life screwing around
Sifting through what works
garbage
and what doesn't
data
work.
to see. Yeah, exactly.
If it doesn't work, we'll give it to you anyway. We've been wrong before, but we'll separate it. saying
It'll be in
that-
like a folder called "This data is probably garbage," or I think the folder is called "Bad."
Yeah, or it's incomplete or not valid. Not
Yeah,
valid. There'll
not
be
valid,
some
yeah.
easy. This is good. This is bad. This stuff maybe works, partially works. This is damaged, but it'll work. It's a video that'll be choppy, but it'll play.
And if there's one video that you're after because you're a wedding photographer or videographer, and boy, I really need the Joneses wedding, like we will actually have a human liaison on it, and
We can render contact sheets for photographers, or your family photos. Basically, see a thumbnail of every image we've recovered.
or if you're an accountant and you're after the QuickBooks file for 3 or 4 companies that hadn't been backed up, we will test those as well. So we're always here to help and make sure that you make a
Well-informed decision. You know exactly what you're going to get. There's no surprises when you give us a credit card.
All right, so that's kind of reformatting. Ransomware is kind of the next nasty word I put up here. Greg, what is a ransomware?
Well, ransomware is basically a piece of malware that prevents you from accessing your important data with hopes of extorting money from you.
Yeah, and it sometimes is malware. It's also sometimes just a dude. Yeah, I mean, sometimes it's just a dude. Probably from Romania. No,
you're gonna get some
no offense, Romania.
No letters. Don't send us letters. We probably still write letters in
Yeah,
Romania.
man, we see, but it's a person that hacked your network, that got on your machine and decided to encrypt all kinds of data, did a bunch of logical damage. So believe it or not, we can sometimes recover a whole bunch of data without necessarily paying that bad guy or bad gal the ransom. And how might we go about that, Greg?
Sometimes they don't do a very good job encrypting the data. For example, a lot of times if there's going to be some sort of threshold where if a file exceeds a certain size, they're not going to bother encrypting it. They're just going to damage it in some way.
Or delete it. Unallocated. So a lot of times...
Because again, they've got a limited time. They want to do as much damage as possible. If they spend an hour encrypting a file that's 2 gigabytes, or maybe that's not quite accurate, but if they spend a lot of time on a certain file, there's a chance you may not even care about that. So large files, basically, they damage or delete, and then small files, they'll actually go and encrypt.
See, so sometimes, and it's a lot of times it comes down to what permissions they have. Sometimes they'll have permissions to delete, but they don't have permissions to access or overwrite. I mean, I've seen it. Sometimes they'll, the actual device that they're trying to get rid of a backup on is a device that's on a network share and it has different permissions to get to it, and they'll do something that's short of encrypting it in place, to Greg's point. Sometimes these volumes have volume shadow copy or some sort of snapshotting on under the covers. Sometimes they don't have permission to modify that snapshotting. Sometimes they do, but they almost never are going to have permission from the operating system to encrypt those snapshots. So sometimes they'll dump or delete the snapshots, but they're still sitting there for our people to hunt down and sometimes utilize. So long story short, all ransomware cases are covered by our digital forensics firm. That's a lot different than how the recovery labs work, but there can be some similar personnel on some of these cases. And the last word I have up here, and hopefully you're not still watching this waiting for us to talk about deleted LUN, but Greg, what the heck is a LUN?
LUN it stands for logical unit. It's basically a disk, but in this context, it's going to be a virtual disk running on some sort of hypervisor. So that's going to be ESXi or Hyper-V. It's basically, there's a lot of other NAS applications that'll basically are going to be exposing a file on a file system as a disk to something. So to the machine that it's accessing the file, it looks exactly like a disk, but it's not a physical disk, it's a file on some big expensive server.
Is that right?
iSCSI, that's a very common way of
So what's an iSCSI, Greg?
iSCSI is basically talking SCSI over the internet. So instead of talking, SCSI is just a command set, and it's also a physical. SCSI is basically a way of talking to storage devices. And that can be to a directly attached disk over, your SCSI port or SATA port on your motherboard, or it can be over the internet. And the beauty is that disk is stored and hopefully backed up and all sorts of good redundancy stuff on a server that's far away, but to the local operating system, it appears just as a disk that was plugged into the motherboard.
And our customers don't have that luxury, right?
Mm-hmm.
If you're watching this, it's usually because, and especially if you're watching this part where we talk about iSCSIs, it's usually because there's actually a SAN
Mm-hmm.
or a very high-end NAS, and it has a whole bunch of storage, and it's carving out chunks of it, and it's then feeding a hypervisor or feeding some other operating system. And the mechanism for doing that is it creates these individual files, usually on like a Linux file system. Don't pick that up. And sometimes somebody pushed the wrong button on a console and deleted it. And then the phone started ringing off the freaking hook, and 43 people were wondering, where's
the company share?
Where'd my company share go? Why did my CRM start working? And then the IT guy's like, what button did I just push? And then he usually freaks out big time.
Oh no, that wasn't the test environment, that was the production environment.
Yeah, and then he goes to the backup and realizes that a third of those systems haven't been backed up in 6 months, and then he calls us, starts watching YouTube videos, and long story short, if you're in that situation, very, very difficult to estimate pricing, very, very difficult to estimate feasibility. These cases traditionally will take dozens of hours of computer scientists. So you can kind of safely say that if you've deleted a LUN that was feeding a hypervisor, I can kind of safely tell you that you're probably looking at like a low 5 figures at kind of a minimum, because you're probably going to rent a big brain guy like Greg for a week, or more sometimes. It's a really bad situation. You'll probably end up talking with one of us, or maybe Nathan or MJ or somebody else on that type of team before you send it in here, but certainly that's not going to be the kind of thing where we can give super accurate pricing on a YouTube video. You're just going to have to pick up the phone and give us a ring. So in general, I think it's safe to say that we prefer when equipment's broken.
Yes.
Because it's usually cheaper and easier to fix equipment and get perfect data than it is to take perfectly healthy equipment.
Try to undo some very destructive operation.
Yeah. And again, if you're wondering, can Gillware help me? What is this going to cost? The very best way, pick up the phone, call the recovery advisory team.
Call now. I feel like you're saying
call now. Call the recovery advisory team. They're very friendly. You're not going to get any kind of hard sell or anything.
Mm-hmm.
They're going to listen to your story, try to give you as little of this mumbo jumbo as they can, with at the same time trying to give you as accurate idea of pricing and feasibility as they possibly can over the phone. So we're here to help, and Thanks for watching.
Feel free to give us a call. One of our client advisors would be happy to talk about your specific situation and figure out how we can best help you.